Alright, hello all, hello world. I am on time for in a move that shocks almost everyone. Yeah, this is day 87 of studying compilers every day until I land a compiler role. Yeah, today I'm a little bit tired and it got really cold outside, so I'm gonna try and minimize the amount of time I take this stream. Yeah, so last time we started cleaning up the tree merging stuff and we re-implemented our tree implementation to be a forest, which is the best name I've gotten for it. Thank you forever whoever it was that suggested it. I forgot who. Or I forgot the username. Yeah, so we're gonna continue implementing tree merging today, and it's gonna be a good time. So yeah, let's get straight into it. So last time we scaffolded out to like this much, and I was running into a couple of issues. The first one was just it's really annoying to figure out, I guess, how to iterate through this range properly. Yeah, so So my thought for this was using another flag and just like while like not processed current node or something, or not processed the leaf node. It seems a little bit choppy, but it should be fine, I think. So let's hopefully we can give this a shot. There was another case I was thinking about that I forgot about. Yeah, okay. This should be fine. So we want like okay. So we want, I guess we want process or like scene leaf. Oh wow, I can't spell. So while we haven't seen the leaf, then or what we could do actually is once we find the leaf, we can do one process cycle and then we can call something in this loop. I don't know. Okay, well we can do this. And then let's get rid of this, and then oh wait, let's take this. We want like, and we can paste this real quick. And we can do this, I guess. Yeah, so we can do that. I really don't like how many flags we have here, so if there's a way that I could cut this number down, that would be great. I guess we could we can one line that as well, and that helps a little bit with cutting down the clutter, but it still is like really gross. I don't really like this. Okay, so we want the next iterator. Yeah, because we want to skip the current one, I think. Right? Actually, yes, we definitely want to skip the current one because otherwise it'll always use leaf, and that's not ideal. Yeah. So we want to increment that. Okay. So now we can start with the inner logic. Also, one thing I need to check is that the current one doesn't use the leaf twice, so we need to check this. So if it's not tree, or there's another condition here. I guess we could just like separate this off. So if this is greater than 2, or greater than 1. I guess we could pop this off, right? We should probably pop this. Yeah, so we should pop that, I think. As we want to pop back. And then we want to check if it doesn't, we want to make sure that it doesn't use the same leaf twice. So if this is the same as, so we want the back one to equal tree and then the second to back to not equal tree. So if this is, or if it's not empty, and what is back actually? What is back if it's empty? Or this is not what I want. Oh, this is not the right. This is not the website I want. There we go. Okay. If it's true, then oh, it's undefined. Okay, so we want to check anyway. So back should, if it equals tree, then we want to continue. Yeah. Oh, but this doesn't work actually. Can we get like first from back actually? Is this a thing? What is C+++? That's crazy. We might be being pretentious here. Oh, we can just prev with end. Okay. Prev end with 2. Right, so we want size. I wrote len because I've been writing a little bit of Rust. Get the length of the array and subtract 2. It's not an array though, it's a list, so it's like a linked list object. So it's easier to just iterate backwards rather than, well, we just can't index, I think. I'm fairly sure we can't index at least. Am I dumb? I might actually be dumb. Let's see. Operator. Okay, there's no bracket operator. Is there an at function? That doesn't help me. Access. Yeah, it's just front and back. So yeah, we have to do this way, unfortunately. Okay, so we want std prev. Prev, and then we want what is happening here? Okay, let's do uses stack and comma 2. Yeah. There we go. Oh, I need to deref it. Whoops. Okay. Trust you. I mean, you're good. It's just like, to be fair, no one uses list, I think, for the most part. So I don't blame you for that one. Okay. So that's the other condition we wanted to check for. So now we can go into the loop proper. So we want to increment, and then there's no risk of like invalidating the iterator, right? Because we're just iterating forward, so we can kind of like do some crazy stuff here. Also, it just occurred to me, because of that, we need to do a while version of this. So we want that, and then it'll make sense why I shouldn't do that, or why I'm doing it like this. Okay, so we have that, and then let's go to the end of this range, and then iter plus plus. Does this make sense? This seems reasonable. I don't know. We'll figure out the logic behind that later. It seems like a start. Okay, so we want to skip if cur uses leaf. So what we could do is we could do the if you go back to where I was doing middle and stuff, and like transform, so like simplify CFG, I did this thing with like lambdas here, as like little sub routines that return a boolean. And then what I did at the end was I just like kind of like this sort of thing. I could probably do that actually. Yeah, let's do that actually. That might make less of a mess. Yeah, let's do that. So I want skip if leaf, lambda, we do that. Like that, and then next one is used by leaf. And then, or actually we could just, so we want uses leaf, and then we want leaf of leaf. And the last one is mem and leaf uses mem and is mem. Or we could just like that is a terrible name. I guess we could do like poisons mem or something. Or I guess we could do maybe aliases or something. I guess we could. What do we call this? Unsafe, or we'll just call it this for now. We can name it later. If I can type, there we go. Okay. So then, oh, I see. We could also do like a prev iter thing as well. I don't know. It's always just gonna make a mess here, I think, with this condition, because we need to check one past pretty much. One past the end condition. So yeah, okay. So given all of these, we want uses leaf or not. We can do this little trick to make this look a little bit prettier. We could do like a true and doesn't do all of these. Yeah, that might actually no. So false, or it uses leaf, or leaf of leaf, We can rename these later. Let's rename this like maybe aliases memory. Alright, how did I format it in the other thing? Because this is bugging me a little. Transforms, simplify CFG. Okay. We turned cling format off. That's how we formatted it. Okay. Yes, let's throw that there. That's pretty funny. Okay. So do that. We can do that. Okay, cool. I should separate this out as well. Okay, I'll need to return things here. Okay, so this means we should not. Yeah, all of this means that we shouldn't try to merge. So we should just continue. And then that gets rid of this can merge thing, which is helpful. We could also throw this at the top, actually. Yeah, let's do that. So we want to increment this first. We could also just stick this here. I lied, we can't do that. Okay, well, that's fine. Unless we parentheses it? Okay, well, let's just do that. Let's just do that. I think this fixes some condition stuff, so I think this is probably fine. Okay. While condition. I swear there was a way to do this. I forgot how to do this. Oh yeah, this is just a thing. Okay, yeah. So we can pull scene leaf equals false, and then do that. I swear there is a case that you can do this. Oh, that's really funny. Yeah, okay, no, we shouldn't do this. Alright, so we can do that, we can do that. Okay. So this should be if cur uses leaf, so we want trees is forest, so we wanna get leaves. And then, so cur uses the leaf. So we're gonna get leaves of cur. And then if it contains leaf, then it's true. We're gonna get leaves of cur. What is cur? Oh, we don't have cur. Oh, we do have cur. That's not what we want though. Cur node equals, or cur tree, I guess. Yeah, so we want this actually, and this is just, actually, do we care about the iterator? I don't think we care about the iterator. So we can probably just steal this. Yeah, this is a node star. And then this can be her tree equals that. Token negative that number? That's crazy work. I feel like that, I don't know, that shouldn't really be a special value. I wonder if you're like adding things instead of like concatenating somewhere, maybe? I'm not sure. That's like the first thing that comes to my mind, at least. Okay, so we want this. This is all cleanup stuff. This is good. Okay, so we want that, and is this the ref? This is the ref. So for auto, this. What type is this? This is a shared putter. If this is the same as leaf, oh, this needs to be in. I've written too much Rust. This needs parentheses. So if that's a leaf, then we want to return false. Can we actually just do that? So what does this do? Oh, this is fine. So if they refer to the shame, oh wait, this is fine. Yeah, then we can skip the get actually. Yeah, so we can do that. Yeah, so we can compare, and then yeah, we can even, that means we can skip a lot of the gets actually. Yeah, we can just work with these shared pointers then. It's a whole lot of convenience. Okay. Okay, so we can just do this, and then we can do this, right? Or do we need to deref this, actually? That's really funny. Okay, well, I can't say I enjoy writing that line of code, but it at least works. Okay, so we do that, and then this needs to be get, at least. Otherwise, we want to return true. Okay, so that one is simple enough. I think I'd want to avoid doing this in like linear time, but it is what it is. Printing part of empty struct, filling it, then printing out the other part. That's crazy. I've definitely heard of worse happening. That's pretty funny though. Okay, so we want a leaf of a leaf. What the fuck? Oh, I see. Yeah, so this is one direction, and then we want the other direction. So if cur uses... Wait, let's open up the slides again. I'm getting confused. Let's pull up the slides. Okay. So we've already satisfied A above, and now we're looking at B. So no uses between and no definitions used by T2. So T2 defines V. Nothing else should use V. So nothing else should have it in its leaves. Yeah, okay. And we just shouldn't be worrying about it if it's in the middle. So yeah, that should be fine. Okay. So V is dead. Okay, so no other use of the V, so if Kerr uses V, or let's like write this out with a notepad because I'm struggling to follow myself. So Kerr doesn't use V. Kerr doesn't use V, or I guess shouldn't use V, and then Kerr shouldn't be used by T2. T2 defines V, so this should be leaf, I think. No, V is the leaf. Wait, what? Used by or Kerr shouldn't be a leaf of used by T2. That is what defines leaf. So that is like iter? What is tree? By tree, yeah, okay. Okay, this is getting really confusing. Everything is named the same. Oh, what's good, Niraj? Good to see you. Okay, I need to figure out this naming thing. So we want let's rename this iter first. It's very generic. So this is let's make this like tree1 iter. For each leaf. Oh, this is awful. So this is for each instruction. So this should be the... Which one are we merging into which? So tree into leaf. Yeah, so this should be tree1 iter. This should be tree1. So we want to get leaves of that. Okay, this is a mistake. Let's do T1. Or iter. Shout out T1. Okay, so we want, this should also be T1. Yeah, okay, so we can do that, and then T1 leaf. I can't spell. Wait. A little segue. Yeah, this is... Okay, finals. Okay, T1's in finals. Shout out T1. I will be watching this at 1 AM, by the way. So if y'all are there, feel free to drop a message in the Discord. Do you find using debuggers with C++ hard? Not really. I think you just have to like not compile, or you just have to like pass the correct flags, and I think it's a little bit easier to follow. I feel like it's I don't really use it to catch like I don't really use it to catch like I guess like issues with like values being wrong. I mostly use it just to like figure out why my code's breaking, like as in like literally side faulting. So I think for that use it's perfectly fine. Just make sure you compile with -g and you should be good to go. Okay, so we should make this T1 uses, or wait, what? Or leaf uses. Yeah, this is a nightmare to make readable. Everything copies 1-to-1? Yeah. I mean, C++ is just like another layer of abstraction, and sometimes you do just have to kind of deal with that. Okay, so we want, there should be T2 iter. Right? Is this tree 2 iter? Yeah. And the leaf should be cur. Right? The leaf should be equal to it. Yes, because it defines this, and it's a tree, so it only grows one direction. Yeah, so we can do this. Okay, so we want scene T2, I think. T1 leaf should just be. Yeah, let's do this. Or we could do T2 scene. Let's rename this. So this should just be T2, I think. Yeah. It's a shared pointer to node. This is a node star. So we want T2 uses. Okay, this actually is way more readable now. Okay, so we can do this, and do that. Yeah, this should be cur tree, I think. This makes sense. Math using compiler development. There's a lot of just like discrete math in terms of like graph stuff, which I think is pretty evident just by looking at all of the stuff that I've been working on. There's not a lot of lineage compared to a lot of things, but yeah, it's all of the math is kind of just like the usual pile that you would see in theory, or like in like algos, sort of. But the rest of the math is like not too complex, I think. Yeah, okay. Sorry, I've been checking Discord. I'm kind of out of it today. So let me just keep the Discord chat up, you know. Big brain 4D chess move? Yeah, that's kind of like, that's like partially what I've been like thinking about here. It's mostly because like I just don't know what I'm doing, or at least I didn't know like up before this project. So this project is just like me getting my shit together and just like actually learning. Yeah, it's like the job market will always be rough for, or like the job market's always like, it ebbs and flows for like the average employee. Is that the term? Surely it's employee, but you get what I mean. But it's always good for the people that are cracked. And my thinking is if it's not great, then I should probably become cracked. So that is the plan here. How many interviews have you had so far? I think 2. Yeah, one of them I got rejected. The other I've accepted. But it's just an internship, so I'm not really counting it for this series. Mostly because it's kind of a loophole to allow me to stream more with the series, because this is quite fun, and I did not expect myself to enjoy streaming as much as I did. Let's actually invert this for readability. Middle school math, grade 6, they don't know enough. Yeah, I guess, yeah. But I think like if you magically like implanted enough knowledge of them from like a discrete math class, I think they would like have enough to at least maybe understand it if someone like broke everything down for them. Because I spent 2 years getting a master's, searched for a job, got a job, got fired. I mean, it'll always bounce back. You just kind of have to wait it out, I fear. All right, we're gonna keep renaming things. So this should be Kerr uses T2. T2 is what we want to merge into it. So this, we want to merge T2 into T1. Yeah. Okay. Yeah, so we can do that. So we want T2 leaf. Or wait. Kerr leaf. Yeah, okay, we can do this like that. So that makes sense. Yeah, so we want no other uses between, so that tracks that one. And then we want no definitions of variables used by T2. So we want, this should be Kerr is T2 leaf. I guess we could do it like this. Does this even, is this like a normal sentence to write? I guess we could do this for now, and then we could like merge some of these together. What's a good one? Okay, so no definitions of variables used by T2. So this is T2 leaf. Yeah, I guess this makes sense. This seems pretty reasonable. Thinking of streaming some LeetCode, Codecrafters, and CodeWars. Ooh, yeah, that seems pretty solid. One of my friends was my inspiration for starting streaming, and they pretty much did a lot of that, as well as like working on projects. So I think that's a pretty good idea, at least. Currently, we're 2 for 2 on people having something to do for the summer since starting to stream some sort of computer science stuff. So, yeah. Okay, so we need to iterate through this again. Will it keep streaming after you land a compiler rule? Yes, that's definitely what I plan on doing. It's just like, it's kind of awkward because I don't really know like what to call the series. That is like the biggest concern I have. And also like just from an algorithm perspective, it's like kind of a big shift. So I'm a little bit scared to see what that does with my viewer base, but hopefully it stays all right at least. Okay, so we want to go through leaves of T2 actually. So you want, this is T2. We'll see how you feel after rolling in dough. I mean, surely, like, if streaming was just about like as much as I tell myself that like streaming is just about like making myself do work, like I don't think it would be as enjoyable as it is for me if I didn't have the opportunity to chat with y'all. So in that sense, I think I would probably keep streaming. Real quick, let me log in for a second. Let me fix this function real quick. So T2 leaf is, so you want leaves of T2, and if that equals cur. Yeah, so this is cur. Wait, cur leaf? No, we want cur tree. Yeah, okay, that makes sense. So we can do that now. This looks really funny. Okay, and then this one I'll worry about in a second. More fun working on Interpreter and chatting, even feeling distracted? Yeah, exactly. Become the god of compilers. Oh, that could be funny. Like day end of working on compilers until I give up and become a farmer in Wyoming or something. I don't know. Something else I was thinking about is like maybe at that point just like streaming a little bit less, but like on a more consistent schedule that's like less just every day, and maybe like a couple days a week, and I could like call it office hours or something. I don't know, but that's like I need to like get to the point where I'm like cracked enough to host office hours. Okay, so we want, okay, so if yeah, okay, so we want to treat a memory use kind of like poison almost, or like if we think about like how poison is used in like LLVM. This is probably not a one-to-one analogy because I still don't fully understand what poison is. But the idea is like kind of a, I guess, potential, like it's a modifier to denote a value that is potentially invalid. So like, it's like this is a value from an operation that could potentially lead to overflow, but might not necessarily. So we want to do something like that with like memory. Or like we want to use that sort of notion with like memory accesses. And like the idea of poison is like you can like propagate it forward. So like if an add operation uses something that like potentially overflows, that result might also potentially be undefined. So we want to propagate poison forwards like that. We can kind of do something similar with like uses memory. Although this is like a little bit more concrete. So I guess it's more like propagating undefined. So like if our instruction uses memory, so I guess like all instructions by default don't use memory unless they are a load instruction, in which case then that uses memory. Or maybe a store, I guess. Maybe a store. Oh, I might need to fix that actually. 1 second. Let me fix that in Gentrees real quick. False. Okay, so load is a read from memory. What is the instance that, I don't know. I guess we could just make this a true for now, or this should be fine, right? Because the read from memory is fine. We just don't want memory to be modified between that point, I think. Right? Because if we're just only reading from memory and allocating memory, that should be safe, right? As long as we don't modify memory, then that should be fine. Yeah, even if we like read from something that aliases, it should be fine. We just can't write to memory. So yeah, the idea is, if you look here, this insert tree thing, this takes the parameters, so it takes the tree, it takes the leaves of the tree, and then it takes a bool which just has memory instruction. And for most functions, they are false because they don't read from memory. Or I guess like don't modify memory, but obviously instruction store will write something to memory. So we will mark that as true here. So yeah. So yeah, that is the only instance that has a memory instruction. And the idea is as we merge trees, if we merge, so if we take a tree that doesn't read from memory and we merge in a tree that does read from memory, that whole tree, the question of like, does this tree read from memory or not? The answer is yes. So in that sense, we want to, I guess, we want to, I guess, we want to propagate that fact that it reads from memory forward, or I guess writes to memory forward. I'm getting mixed up. Write to memory is the unsafe one. So yeah, we want to propagate that forward, and then yeah, so we want to check that here. So if it writes to memory, so if the tree we're trying to merge, actually, both trees. If T2 accesses memory, so if that is the one that we're trying to merge upwards. So yeah, so if trees, what is this parameter called again? This is has memory instruction. Has memory instruction. Let's give it T2. Yeah, so if T2 has a memory instruction and so if it has a memory instruction, then we need to make sure the values in between don't have a memory instruction. Or yeah. So if that and trees has memory instruction. Yeah, and then we can just give this cur. Oh wait, this should be get, or what is cur? Or cur tree get. And then T2 should also be a get. Oh wait, we can just return this actually. Yeah, okay. Okay, I'll show a little trick to make this a little bit prettier, but first I need to actually implement this has memory instruction thing because we're kind of using something that doesn't exist yet. So let's throw this down here. So we have get leaves, and then we want pool has memory instruction node star tree. Yeah, so we can do that, and then this should be really easy to implement. Yeah, so we can also, let me put this on screen, sorry. Let's go to forest, and it has that. Return has memory, or what is it called? Yeah, this god-awful name. This should just be a set, actually. Yeah, I should make this a set. What am I doing? Yeah, let's make this a set so it sucks a little bit less. Yeah, so we can do this. Or we can like trees with, yeah, we can do that, I guess. How to become rich, learn compilers, make a programming language, make 10 quadrillion libraries. That would work, except for the part that people don't really use it. You should make a compiler where the front end is front end JS and the back end is literally back end. That sounds a little bit too far into the land that I don't want to try, I fear. It's not really my cup of tea. Okay, so we redefine that so we need to update this real quick. So if contains memory. This, then we want trees with memory instruction. We want to insert tree. Oh Jesus! So I'm gonna do that. Get rid of that. Let's go down here. So let's put this here. And we need to. Oh Jesus! What is happening? So this we want contains, right? What type is this? Did I save this? Oh, I need to import set. Whoops. All right. Let's try that again. So contains tree. All right. Contains bool. Okay, this should work. So now this is implemented, but this looks a little bit ugly. So this is a trick that our compilers prof actually showed me in class, and it has stuck with me since, which is the same thing as this sort of thing. The idea is, the problem here is like we can't really rearrange these, and also it's just like really ugly to look at. So what we can do is we can, since these are ands, and constant folding exists, we can just true. And then we can move this to the new line, and then we can stick an and in front here. And then we can... This breaks formatting still, but we can do like this sort of thing. Oh Jesus, what did I do there? Alright, let's do this. And then we can do like something like this. Yeah, so this would be like the pretty way to do this. Unfortunately, Clang format ruins all of my hopes and dreams, so we will have to do this the ugly way. Okay, so up here though, there is a chance we want to reorder these, so this actually matters a lot more. Okay, so if cur is a leaf of T2, or it uses T2, is this the correct order that I want? Uses or is leaf. Yeah. Uses or is a leaf, or maybe aliases memory. Then we want to skip it. Otherwise, we want to merge. Yeah, so here we want to merge. And let's get rid of this comment. This, we iterate properly now. Okay. Alright, so the merging will be a little bit more involved. I could do this now, but I'm also kind of tired, so I kind of don't want to. I don't know, today's just been a very slow day. Okay, what we're gonna do is, also we need a way to get cur, because cur is like empty, right? Oh yeah, we need a way to get it from trees. Uses should be empty. This is, or wait, we need to fill these, right? Oh wait, this is a lambda inside a lambda. What am I doing? Okay, no, so we do just set that up perfectly, so that's fine. Holy hell, what am I doing here? Okay, so we have lambdas inside lambdas here. Holy hell. If this is not nested code, I don't know what is. Oh. Okay. And then the rest of this is fine. You can try merge and then yeah, all yada yada yada. Okay. So then, yeah, so now we want to actually figure out how to merge the trees. So, Huh. How do we even do this? I guess we have to like traverse the tree and then like literally replace it? Unless you want to do like a skip list or something, but... Oh, wait, no. Okay, so we want to replace leaf... putters with tree putters, right? Or... So we want to replace the... So you want to replace leaf with actual T2, right? Wait, what am I? Wait, no, this doesn't make sense. No, this really does not make sense to me. No, we can't compare like this, I think. Yeah, because we make new pointer. Oh, fuck. Okay. Okay, we're gonna need a new way to compare, I think. Alright. I'll figure this out next time. Let me just add a reminder for myself. Alright. I need to commit real quick. More tree merging progress. Alright. I think that's a good place to call today's stream. Thank you all so much for showing up. I know it's a little bit shorter than usual, but that's kind of how it is sometimes. I haven't eaten dinner yet, so I should probably do that. If you're new here, make sure you like the stream and sub to my channel. It helps out a lot with the algorithm and helps get my content out to more of you. And while you're down there, make sure you join the Discord. It's actually somewhat active. It might not be like super active, but there's at least like some group of people. It's pretty tight knit. Everyone's really chill. You should definitely check it out. And of course, you should connect with me on GitHub and add me on LinkedIn. That's the other way around. Connect with me on LinkedIn and add me on GitHub to stay up to date with what I'm doing. So yeah, take care, y'all. Take it easy and have a wonderful rest of your day wherever you are.